Hi everyone, this is Andy here from Simon Fraser University. I'm here to talk to you today about fossil fuels. The purpose of this lecture, which is part of the energy policy course, is to give you a basic introduction to oil and gas. What we'll talk about today is how oil and gas were originally formed, what are the steps in their production process, the importance and variety of different end products that come from petroleum distillation, and the emergence of natural gas and liquefied natural gas as key markets in global energy trade. Now, fossil fuels are exactly what they sound like. That is, they are previous life, whether they were dinosaurs or other living creatures or plants that died millions of years ago and whose remains were trapped beneath the surface, sometimes compressed by rocks, by sand, and eventually have turned into hydrocarbons, oil and gas deposits that provide a very ready and accessible and powerful source of energy that has basically fueled the world economy over the last century. Now, if we want to reach these oil and gas deposits, we have to use a drilling mechanism. So the petroleum drills will create a circular motion. They'll drill through silt, sand, and rocks until they reach the coveted oil deposit. Oftentimes with oil deposits, we find natural gas deposits as well. Traditionally, these have been flared, but more recently, as we'll discuss momentarily, natural gas has become a product in and of itself. There's some terms that you should be aware of when we talk about oil markets. One is light versus heavy. Light tends to have less additives and residues and therefore is more coveted. Similarly, sweet has less sulfur, sour tends to have a lot more sulfur. So these additives and residues need to be refined before the oil can be used. A third term that you're probably familiar with is tar sands. This is oil that is trapped within tar. Obviously, we're referring here to Western Canadian oil deposits. It requires huge amounts of chemicals and waters to release that oil and therefore has a higher price point. And then last but not least, we're talking about on versus offshore. So offshore, like heavy or like sour crude, is a much more expensive way to pull out oil. But as oil prices increased and energy demand has increased over the decades, offshore oil, including considering the technological advancements that have occurred, has become more and more economically viable. And so what we've seen in energy markets is over time, in fact, as oil prices increased, we never reached the feared situation of peak oil. Every time oil prices increased, we found new unconventional sources of oil. Originally, that was offshore oil, and then eventually it became fracking. Now, when you're refining oil, you use the tried and true technique of distillation. Distillation is boiling off a liquid so that it turns into a gas. And as it turns into a gas, the different elements can be separated. And so in petroleum, what we see is the heavy residues tend to be used for asphalt. The lighter fuels would be used for gasoline or petroleum. Some of the lightest fuels are used for jet fuel. But all of these different elements have important uses in terms of energy. Energy, as you know, it's used for heat, and it's used for transportation, and it's used for electricity generation. And in fact, there are a very wide variety of products that come from distillation of crude oil. We have LPG, or liquefied petroleum gas, that has been increasingly used in marine applications because it has a lower footprint than diesel marine fuel oil, which was the traditional source of fuel for long-distance transportation by ship. We have a variety of petrochemicals that derive from crude oil, gasoline, jet fuel, those are different products, and diesel fuels. As you know, some automobiles also take diesel fuels, but they're primarily used in railways. We have a variety of other petrochemical products that are vital to our industrial complex, lubricating oils, waxes, and polishes. and then, of course, asphalt, bitumen for roads and for roofing. Now, one of the most important byproducts of crude oil refining is plastics, something that we haven't really been able to find a good substitute for. And so that suggests that it's possible that we will continue to have to use fossil fuels to some extent, even as we start to move to a clean energy transition. Of course, one of the problems with plastics, like the problems that we have with fossil fuels, is that not only do they pollute the environment, but we have very few ways to actually remove them from the environment that are economical. Let's turn now to natural gas and how natural gas works. Recall that natural gas is a general byproduct of oil, but sometimes it's found in deposits on its own. And natural gas technologies have improved to the point where in the 1970s we had the introduction of the combined cycle gas turbine. This allowed for natural gas to be used on a large scale level by the 1980s and 1990s in electricity generation. Natural gas has a much lower carbon footprint than coal, and it has become cheaper than coal. And so that explains a lot of displacement of coal in energy markets. And one of the things that revolutionized the natural gas markets was the development of hydraulic fracturing techniques. These are new types of drill bits and new types of drill techniques that allow one to drill through shale rock, heavy rock, in a diagonal or horizontal way to be able to get at unconventional deposits of oil and natural gas. And in fact, we found large deposits of that gas in the Midwest and in northeastern part of the United States, which has allowed the U.S. become one of the largest exporters of natural gas in the world. There are concerns about fracking, as you probably have heard. There are concerns about contamination of water and concerns about the heavy chemicals that are being used. In order to drive out the natural gas, one tends to pump chemicals and water into the deposits, and then the natural gas will be forced out. And so this illustration here shows us the unconventional drill bits that were built up for fracking, as well as the unconventional types of new drilling techniques and angles that were used to develop the fracking industry. Now, the natural gas industry is become an industry in and of itself. Originally, as I said, it was often vented and flared in oil rigs. It still happens sometimes, especially in offshore oil rigs where it's difficult to separate out and refine that gas because the gas is not a liquid. Unlike oil, it's odorless and colorless, and it needs to have a specialized plant to be compressed. Sometimes in an oil rig, they will burn the gas right there as a source of heat or energy, but increasingly what we have are new gasoline refining and compression stations. And those compression stations are linked pipelines that allow the natural gas industry to ship its natural gas to houses and companies that need to use it directly for heating, or to utilities that will burn it to create electricity. Now, one of the most important new developments in fossil fuels is the development of LNG, or liquefied natural gas. Because one can't send pipelines across the ocean, we have developed all kinds of new techniques, including new shipping, new ships, new types of compression at ports so that the natural gas can be cooled to such a temperature that it actually becomes liquefied. And then with the specialized tankers, one can ship it overseas. It is then decompressed at that port and sent via pipeline to the consumers. And so the LNG market has become one of the most important new markets for fossil fuels. Now, as we start to think about some of the things that we've talked about, let's try to recognize that oil and gas are a very technology and capital intensive industry. Relatively speaking, they don't create that many jobs. recognize also that every time the price of oil is increased, the new techniques have been able to find unconventional sources of oil, so it's never really run out. And we need to recognize, above all, that oil is not just used in gasoline in cars, but it's used in a wide variety of economic sectors, including plastics, and that's what makes it so incredibly difficult to replace oil with any kind of substitute. Um, Nonetheless, we've also discussed in other lectures that, at least for electricity generation, the technologies of wind and increasingly solar are within reach and competitive with natural gas, and certainly cheaper if we consider the costs of pollution. So electricity generation tends to lend itself a little bit more easily to the clean energy transition. But something like plastic, something like petrochemicals that are used in industry, and more refined sources of energy like jet fuel are still difficult to replace based on today's technology. Let's hope that changes, and I hope we can take a few minutes as well to think about the question about carbon lock-in, how difficult it is for us to think across different sectors and think about ways that petroleum could potentially be replaced in the future in order to save our planet. I look forward to discussing this question with you.